Now, sometimes you also see trig expressions that combine exponentials and logs as well. Here we're going to focus on logs, but again, you can see different kinds of functions combined sometimes. So as a quick review for your logs, assuming that m and n are both positive, remember that the natural log, so this is ln, natural log of 1 is 0, the natural log of e is 1, the natural log of e to the x is x, and e to the natural log of x is x. So these two, when you compose those functions, cancel each other out. They're inverses. We also know that when we multiply something, the natural log of that multiplication can be separated out into the natural log of m plus the natural log of n. Similarly, when we divide, we can separate that out into natural log of m minus natural log of n. And the other one is that when you have an exponent, that exponent can become out front and be multiplied as a factor with logs. So that is the last rule here. So let's do a couple of examples here, applying both trig identities and these natural log rules. So in our first example, we want to show that the natural log of secant and negative natural log of cosine are equivalent. And there really are different ways to do this. So I'm going to show you just one technique, but there can be others as well. All right, so if we're saying that they're equivalent, we really are saying that they are equal. So this is another example of showing it and verifying an identity, just a different way to word it. So I'm going to go ahead and in this case, I'm going to start with the left-hand side here. Now, both sides are pretty similarly difficult. However, if I see secant, my brain is to jump to 1 over cosine. So I'm going to go with that strategy here first. So let's start there. So for secant, I'm going to change that over to 1 over cosine of x. Now, again, there's more than one way to do this. I can think of a couple in my head right now, but one way is to recognize that when we are dividing with logs, we can rewrite it as subtraction. So I can rewrite this as the natural log of 1 minus the natural log of cosine x. So I have the natural log of 1 and cosine x. Now, one thing I will note is, remember, for the log rules to work, your m and n have to be positive, and our trig functions aren't always positive. So this is going to actually stay in an absolute value instead. Now, 1 is positive, so it's not an issue. The natural log of 1 we know is 0. So this becomes 0 minus natural log of the absolute value of cosine x, or just cleaning this up, we don't really need that 0 there, negative natural log absolute value of cosine x. And that was what we were trying to show. So we are done. Now, another way to do it too, and again, I won't show you every single possibility all the time, but just something else to note here. So another way to run through it instead of using the subtraction rule is to say, well, I actually could rewrite that as cosine x to the negative 1, right? Because negative exponent means to flip. So what I could do is I could rewrite that. And then what happens is this negative 1 can come out front as a factor. So this is another way to get the same result, right? So again, there's often more than one way to do it. Some ways may be faster than others. So, I mean, ideally you would find the fastest way to do it, but if you can find a strategy that gets you to that verification, then that's fine. I'm going to do one more here. This one's going to be a bit more complicated. So we're going to show the pair is equivalent again. We're going to use negative natural log absolute value cosecant x plus cotangent x and natural log of cosecant x minus cotangent x. So remember, equivalent means equal. So we're trying to show that really this is equal to this. So it's just another way to say, hey, show that identity is true, verify that identity. So that's what we're going to try to do here. Now, again, both sides kind of look equally difficult. I don't really like either side in particular here. So I'm going to go ahead and start simplifying. I'm just going to choose the left side to start with. Now I'm going to veer from my usual rule of whenever I see cosecant or cotangent to put everything in terms of sine and cosine. And the reason I'm doing that is because my end result is still in cosecant and cotangent. Like I said, normally I would change these over to sines and cosines immediately. That's usually my first strategy. However, I'm not going to do that in this case. And the reason is because the end result is not in sines and cosines. My end result is still in cosecant and cotangent. So if I change them to sines and cosines, I'm just going to have to change them back later. So I'm going to try to do it without changing them over. And again, not to sound like a broken record here, but the only reason is because of the end result, right? My end result here looks very similar to my beginning result. So I'm going to try to avoid that changeover. One thing I do note here, though, is I do see this outside negative. Remember, for the log rules, those outside negatives are really exponents, right? Factors and exponents are interchangeable. So I'm going to go ahead and bring that on the side. So it's going to be -1 here. So this whole thing is sort of in the log like this. And I guess I could have written, I'm trying to look at it now, I guess I could have written my last example like that as well. So perhaps I should have written it this way. That would have been a little bit better to write it like this instead. Okay, so we have that piece here, and you want to remember that a negative exponent means to flip. It means to take a reciprocal. So I am going to rewrite this as natural log of 1 over the absolute value of cosecant x plus cotangent x. So we're going to go ahead and flip that piece there. And again, I guess you don't really need the outside parentheses here. Sometimes I just like them to make it a little clearer for myself. All right, now here, again, I'm kind of really getting stuck here, but I do know I want my final result to have a positive and then a negative in it. So my thinking is, well, let's multiply by that and see if we can get it to look like that instead. So that's kind of what I'm thinking here. So I'm going to rewrite this natural log. So I have 1 over secant x plus cotangent x. And I'm going to multiply that by the absolute value of cosecant x minus cotangent x. But I can't just do it on the bottom, I have to do it on the top as well. So multiplying the top by 1 isn't going to change anything. On the bottom, even though they're in absolute values, you actually can still FOIL this. So you would have cosecant squared x plus, or I guess minus, sorry, minus cosecant x times cotangent x on the inside plus cosecant x times cotangent x, and then minus cotangent squared x, absolute value. And you're going to notice that those inside terms are going to cancel. And you're left with natural log of absolute value cosecant x minus cotangent x all over absolute value of cosecant squared x minus cotangent squared x. Now, if you go back to your identities, this is not one that we use very often, but there is one that relates, a Pythagorean identity that relates cosecant and cotangent. So it's 1 plus cotangent squared x equals cosecant squared x. So I'm just going to write that down here. That's not quite what I have, but we have something very similar. If I subtract the cotangent to both sides, right, bring that over, then I have 1 equals cosecant squared x minus cotangent squared x. So I'm able to go ahead and make that substitution and substitute that value out for 1. Now here, you're gonna have the absolute value of 1, which is just 1. And you don't even really need that denominator, right? Dividing by 1 doesn't change anything. So we have absolute value of cosecant x minus cotangent x. And finally, we are done. So that was what we were looking to show. If I go back up to the top, that was what we were looking to show. This one is actually pretty complicated. If you look at it, you sort of just think, yeah, but it's just a negative. That's all we did was change a negative over. But using the rules, it's not quite as simple. That negative comes in as an exponent, not as a multiplier. So it comes in as an exponent. That has us use the reciprocal rule. That really didn't help me too much. I really wanted to have cosecant minus cotangent x in my numerator. So I said, well, let's just multiply by it. But you have to multiply on top and bottom. And by doing that, I was able to actually clean it up a bit and get to that final answer that I was looking for. So again, this one's a really tough one where we had to use some different strategies that we haven't seen as much, or we've tried some new things, like not changing to sine and cosine to see if we can get it to work. As I mentioned before, there's always more than, or I should say always, but there's usually more than one way to do it. And as you're going through these, you may find that some strategies are easier than others. Or even, for this one here, the one I just did on the page before, you may say like, oh, this strategy is way easier. Oh, this strategy is way easier. As long as you can get the right answer and can verify the identities, it really doesn't matter. Obviously, you want to make your life as easy as possible, but what's easy for one person may be more difficult for another. So find the strategy that works for you. If you see something that's working when solving these little puzzles and you're getting to the right solution, then that's great. So there's more than one way to do it, and that is often fine.